Good day, everyone. Welcome to this lesson video on two-way analysis of variance. But before anything else, please allow me to start with a prayer. Dear Heavenly Father, thank you for this day. We just want to acknowledge that you are the source of all wisdom and understanding. We pray, God, that you bless us in this endeavor. Help us that in everything we do, we may glorify you and lift up your name, and your name be praised. You may have the preeminence in everything. Lord, help us, even the viewers of this lesson, give them understanding, and may they be reminded that you are always and ultimately the source of wisdom. And this we pray and we acknowledge through your Son, Jesus Christ, who died on the cross for our sins, was buried, and rose again on the third day. Bless us, dear Father, in Jesus' mighty name we pray. Amen. Okay, so hello everyone. So in this lesson video, I will be discussing about two-way analysis of variance, how to cast the problems and the hypothesis, when to use two-way analysis of variance, how to conduct two-way analysis of variance using the real stat, and how to report the results. We have here two-way analysis of variance is otherwise called as the two-factor ANOVA. It is called the two-factor ANOVA because the independent variables in the study, in the analysis, are considered as factors. So a factor refers to an independent variable, and it may also be called as a main effect of factor A or main effect of factor B. Now, it's called two-way analysis of variance because this analysis is used for studies involving two independent variables or two factors, analyzing their effects, their main effects on the dependent variable. Now, each factor in a two-way ANOVA has two or more levels or conditions of the independent variable. Each factor has two or more conditions or levels. So in a two-way analysis of variance, it involves a study that has two factors. Thus it is called two-way because there are two factors or two independent variables, and each factor has two or more levels or conditions. For example, we have here a two-factor study. Let's say the effect of therapy and Prozac on level of depression. So we have two factors or two independent variables, therapy and Prozac. And we have one dependent variable, which is measured on a continuous scale. It is independent or ratio scale. So we have the level of depression. We have depression as measured on a psychological test, on an inventory. These are scores of depression. And we have therapy with two levels. The therapy condition, the with therapy condition, and the no therapy condition. And the second factor, which is medication, the first condition is Prozac. This is the condition using Prozac as a medication, and another condition uses no Prozac or the control group. So this is a study which is named as a 2x2 factorial design. This is 2 because there are two levels of the first factor. Then times 2 2 by 2, the other factor has two conditions also, that hence it is called 2 by 2 factorial design. So all in all, there are 4 conditions with 2 conditions for each factor. Another example would be a 3-factor study. This time, this would involve a statistical analysis, which we call a 3-way ANOVA. For example, you don't only consider therapy and the use of medication, but you also consider the gender of therapists on the level of depression of your clients. For example, you are a psychologist and you want to know what is the effect of these factors, of these independent variables on the level of depression of your clients. So you have determined 3 factors: therapy, Prozac, or the use of medication, and the gender of therapist. So for therapy, you have 2 conditions: the with therapy condition and the no therapy condition. And for the medication factor, you have the Prozac condition and the no Prozac condition. And for the third factor, you have gender of the therapist. We have the male and female therapist. So you want to know, will there be significant difference in level of depression between clients who had therapy and no therapy, and between clients who had Prozac and no Prozac, and between clients who had male and female therapists. So in this design, you have a 2 by 2 by 2 factorial design. 8 conditions in all. 2 by 2 2 by 2 by 2 factorial design. The advantages of using two-way ANOVA. One of the advantages of using two-way ANOVA is that it decreases the cost, meaning to say we increase our efficiency by using two-way ANOVA. Instead of carrying out 2 separate studies, because remember, if you are conducting two-way ANOVA or two-factor design studies, you are investigating the effect of 2 factors on your dependent variable. So one way to do that is to carry out 2 separate studies. Okay, one study would be investigating on the effect of the first factor, and then another study would be investigating on the effect of the second factor on the same dependent variable. Now, with the use of factorial design studies, using two-way ANOVA as your statistical analysis treatment, then you can now carry out a single study investigating on the effects of 2 independent variables on one dependent variable. So that would be 2 studies in one. So you are shooting 2 birds with 1 stone. Then another advantage of using two-way ANOVA is that you're not only studying the main effects of 2 factors on the dependent variable, but you are also studying the interaction of these factors on the dependent variable. Because of the real world of research, the effect of a single independent variable is rarely unaffected by one or more other independent variables. The study of interaction among the independent variables may be the more important objective of an investigation. If only single factor studies were conducted, the study of interaction among independent variables would be impossible. So in addition to investigating how different levels of the 2 independent variables affect the dependent variable, we can test whether levels of one independent variable affect the dependent variable in the same way across the levels of the second independent variable. If the effect is not the same, we say that there is an interaction between the two independent variables. Now, the third advantage of using two-way ANOVA is that it increases statistical power due to smaller variance. Power, as you may recall, is the ability to confidently reject a false null hypothesis. This type of research design increases statistical power because the within group's variance tends to be smaller than the within group variance of a comparable one variable study. So it should be two one-way ANOVAs. The smaller the variance, the less fluctuation in measure. Another advantage, hence you're increasing the statistical power, is that there is control over a second variable by including it in the design as an independent variable. So these are the advantages of using two-way ANOVA. It is more efficient. It enables us to investigate main effects and the interaction of effects, and it also increases statistical power. When you say main effect, it refers to the effect that one independent variable has on the dependent variable, holding the effects of the other variables constant. Okay, so when you say main effect, it refers to the effect of an independent variable on the dependent variable separate from the effect of the other variable. Alone, on its own, we investigate the effect of one independent variable on its own on the dependent variable. Now, when we say interaction of effects, interaction indicates that the effect of one variable is not consistent across all levels of the other variables. That is, the relationship between one independent variable is different at different levels of the other variable. This is the situation that we call it depends. For example, we find that there is an interaction of effect of education on voting behavior of voters. So there is an interaction of effect of education, gender on voting behavior. So we say voters, educated voters are more critical in their voting behavior if they are males, okay, than if they are females. So education has effect on voting behavior depending on the gender of the voter. So that is an example of interaction of effect. Ito yung mga example ng interaction. Okay, so it depends. The effect of one factor depends on the effect of the other factor. Okay, so that is one benefit of using two-way ANOVA. We're able to see the interaction of effects. Now, based on the graph of mean scores, we can plot, we can see if there would be interaction of effects based on graphs of mean scores. I have here a picture of 4 different graphs showing different scenarios of results from an analysis of variance, two-way analysis of variance. So we have here 2 factors, factor A and factor B. Now, here in this x-axis, we have the levels of factor B. So there are 3 levels of factor B. So we have level 1, level 2, and level 3. And here's here represented by level 1 of factor A, and the diamond here is represented of level 2 of factor A. So there are two factors being represented in these four graphs. So if you will plot on the y-axis the scores on the dependent variable, ito yung mean response, and these are the conditions of factor B. And ito naman yung dalawang lines here, the two lines here represent the conditions of factor A. So in graph A, let's say for example, we have already performed the two-way analysis of variance. We have conducted the study, collected the data, and then performed the analysis of variance, the two-way analysis of variance. There are four scenarios that we can get, okay? There are four possible scenarios. So we have here in graph A, it depicts a picture wherein factor A is significant, as you would see that the scores of level 1 and level 2 for factor A are really far from each other. Level 1 is much lower in mean response than level 2. Level 2 mean scores, ito na mga square, depicted by square symbols, they are much higher here on our Y scale, the mean response. So they are significantly different. Now, if we will try to compare the mean scores of people based on their levels on factor B, level 1, level 2, and level 3, there are three conditions of factor B. So we can say that this study is a 2x3 factorial design. There are two conditions for factor A and three conditions for factor B. So the mean scores for level 1 and level 2 and level 3 are just about the same. Okay, so factor B is not significant, and there is no significant interaction between the two factors. We can we can see that there is no significant interaction between the two factors because the lines do not, there seem to be no appearance of converging or diverging between the two lines. Okay, they are parallel. They are parallel with each other, these two lines. Now, in graph B, this is a situation wherein factor A is not significant. You can see that the diamonds and the square points here are just about near to each other. However, factor B is significant. The scores of people along the points of the different levels of factor B are, you can see they are significantly different. For level 1 of factor B, it is very high above here. And for level 2 of factor B, it's very low down here in the mean response, and then it goes up again for the third level of factor B. So there is a significant difference among the scores here. But we can see also that there is no significant interaction between the two factors because you can see that the lines are just about parallel with each other. So there is no way that we can see some kind of converging or diverging between the two lines. Okay, so that is graph B. Now in graph C, we can see that both factors are significant, but there is still no significant interaction between factor A and factor B. You see that the two lines are far from each other, and the diamonds in the squares are not leveled off, unlike this one here. So they are, you can see that the level 1 for factor B is high, and it goes down for level 2 of factor B, and it goes up again. So they are different. So the two factors are significant. They have significant main effects, but no significant interaction. Now, in this graph showing graph D, it shows us that there is a significant interaction because the lines here are converging. Okay, at some point, the two lines crossed, showing us that there is an interaction, significant interaction between the two factors. And if this is the case, that there is a significant interaction based on this, we cannot proceed with discussing main effects. Okay? We should avoid interpreting or discussing main effects when significant disordinal interactions are present. For example, in the present case, the results for the F test of the main effects should be reported if there is a significant main effect, but interpretation should be limited to the significant interaction effect. Okay, so makita natin dito that level 2, okay, level 1 and level 2, they diverge. Okay, so level 1, they are just about the same. However, when it comes to level 2, the level 1 and level 2 of factor A are just about different. Okay, so the effect of factor A differs depending on which level of factor B it is in. Okay, so makita natin dito. And when it comes to the third level of factor B, the effect of factor A, they crisscross, nagbabago. Kung dito ang level 2 pababa, pagdating sa level 3 ng factor B, si level 2 ng factor A ay pataas. So we can see that there is an interaction of effects. So we can say that the effect of factor A is dependent on which level of factor B that is in that we are talking about. So that is an interaction of effect. So for us to determine that, we have to state 3 hypotheses. Okay, so we have 3 hypotheses here. We create hypothesis for factor 1, and then we create hypothesis for factor 2, and then we create hypothesis, a set of hypotheses for interaction of effects. So for the null hypothesis for factor 1, we say, for example, I got here a study data set for the effects of therapy, the type of therapy used, and the gender of counselor on alleviation of grief among clients, counseling clients. So our first factor would be type of counseling, and our second factor would be the gender of the counselor. So we say in our null hypothesis for factor 1, type of counseling, that there is no significant difference in grief scores among clients that went through different types of therapy. And the alternative hypothesis would be there is a significant difference in grief scores among clients that went through different types of therapy. And then the main effect for factor 2 that refers to gender of counselor. So there is, the null hypothesis would say that there is no significant difference in grief scores between clients under male and female counselors. And the alternative hypothesis would be there is a significant difference in grief scores between clients under male and female counselors. Then we have another set of hypotheses for the interaction of effects. The null hypothesis would say that there is no significant interaction of effects on the client's grief scores between type of therapy used and gender of the therapist. And the alternative hypothesis would say that there is a significant interaction of effects on the client's grief scores between type of therapy used and gender of the therapist. Okay, so we set our alpha at 0.05. The assumptions of two-way ANOVA are the same with that of the one-way ANOVA. So we have normality of distribution. This one we can check through looking at the skewness and kurtosis and even testing like Shapiro-Wilk. Then we also have another assumption, the homogeneity of variance. This one you can check through Leven's test. And another assumption is that the samples were independently and randomly chosen from the population. This is part inherent in the design of the study. This should be part of the design. Then however, if there are violations, the two-way ANOVA is robust to violations of assumptions, particularly when there are large and equal number of observation in each cell of the factorial. On to performing the two-way analysis of variance, we just have to control M. So we have here the ribbons here. We click ANOVA, then click two-factor ANOVA, and we click OK. Okay. So we have here we now highlight. So I got here how many are this? We have 5 for each row. So 5, there are 30 clients here. There are 5 clients who had male counselors and went through emotion-focused counseling. And then we also have 5 clients who went through a male counselor and had a psychoanalytic type of counseling. And we also have 5 clients under a male counselor using behavioral counseling, type of counseling. And then we also have 5 clients under a female counselor, and emotion-focused counseling was used with them. And another 5 clients who had psychoanalytic type of counseling under a female counselor, and another 5 clients who had behavioral type of counseling under a female counselor. Okay, so I will now highlight. The first one is we will input the data range, highlight this. So we have Excel format, row column headings included with data. And we check ANOVA, and we have fixed. We have fixed independent variables. what is a fixed independent variable? If the levels of an independent variable were selected by the researcher because they were of particular interest and or were all possible levels, it is a fixed model or fixed factor or effect. In other words, the levels did not constitute random samples from some larger population of levels. The treatment levels are deliberately selected and will remain constant from one replication to another. Okay, then we also have a random models, wherein if the levels of an independent variable or factor are randomly selected from a larger population of levels, that variable is called a random model. The treatment levels are randomly selected, and if we replicated the study, we would again choose the levels randomly and would most likely have a whole new set of levels. So there is also a mixed effect wherein one independent variable could be fixed and the other independent variable could be random, and we call it a mixed effect model. So let us just presume that this is a fixed model. Both factors or independent variables are fixed. Okay, so we have number of rows per sample. So this is one sample. So we have 5. 1, 2, 3, 4, 5. And we choose our output range. I will put the output range here and click OK. So here we can see that. So these are now the descriptive statistics. There are 5. So these are the counts. There are 5 for each cells. So we have 30 all in all. And these are the mean scores in Grief's, the Grief mean scores. Okay, so this is the mean score, Grief mean score for the group with who had a male counselor using emotion focused. And this is the Grief mean score of clients who had male counselor using psychoanalytic type of counseling. And then the other one is, the other group is, this is the mean score for the clients who had male counselors using behavioral type of counseling. And for the females, we have here the mean score, 159.6. Okay, the clients with a female counselor using emotion focused. And 140.2 is the mean score of clients who had a female counselor using psychoanalytic type of counseling. And this is the mean score of clients who had a female counselor using behavioral type of counseling. Now, for the male and female, these are the mean scores regardless for the type of counseling. These are the mean scores of the clients under a male counselor, 150.8. And this is the mean score of the clients under a female counselors, regardless of type of counseling. So that is 155.06. Now, this is now again the mean score of clients under emotion focused, regardless of gender of the therapist or of the counselor. And this is the mean score, 158, of the clients went through psychoanalytic counseling, regardless of the gender of the counselor. And we also have here the mean score, which is 153.3, of the clients who went through behavioral type of counseling, regardless of the gender of the participants. So, and these are now the variances. And after ANOVA, so we see here our decision rule again is our decision rule to reject HO, the p-value should be less than 0.5. Okay, so we have here for the rows, these are now the rows. Ito, males, the rows are represented by gender of the counselor. So ito, gender of counselor. Okay. And the columns represented by factor factor A. So this would be type of counseling used. So we can see that the p-value, the F statistic of 0.303 has an equivalent p-value probability value of 0.58. 0.5869, so that would be rounded off to 0.59. 0.59 is greater than the probability value of 0.05. Okay, it is greater than the alpha level of 0.05, I mean. So we accept the null hypothesis here. Accept HO. And the same thing also we have for the type of counseling, okay? This is now the columns which represent the type of counseling. So this would answer the question, is there a significant difference in grieving scores among the clients who went through different types of counseling? So we have here an F value of 0.61. It has a p-value of 0.54. The p-value is greater than alpha of 0.05, so we accept HO. So there is no main effect for gender of counselor. There is no main effect for type of counseling, but we can see here that the interaction between gender counseling is significant with an F of 6.61. It has a probability value of 0.005. So we reject HO, meaning to say that there is a significant interaction between gender of counselor and type of counseling on the grieving scores of our clients. So let us try to see, we'll try to see the graph here. We look at the mean scores dito sa descriptive statistics natin, and we will plot a graph. How does it look like if we draw a line at a chart? So we have the chart showing the mean scores of our participants and including both factors. So we have here the chart for, so on the x-axis, we show here the three types of counseling. We have the emotion-focused, the psychoanalytic type of counseling, and the behavioral type of counseling. And over here on the y-axis would be the scores on grief scale. And we have these two lines. The red lines represent the clients under a female counselor, and the blue line represents the scores of clients receiving counseling from a male counselor. So we have here male counselors, clients under a male counselor, and the orange line here represent the grief scores of clients receiving counseling from a female counselor. Now we can see that since based on our analysis of variance, there is no significant difference across types of counseling used. There is no significant difference in grieving scores across types of counseling used. So therefore, there is no main effect of type of counseling. Whatever type of counseling you use, it wouldn't have a significant effect on the grieving scores of your clients. And we also see that there is no significant difference in grieving scores whether the clients went through under a male or female counselor. Okay, so makita natin. However, we can see that the two lines here are not parallel. In fact, they are crisscrossing. There are points of intersection where the lines are intersecting, depicting or indicating that there is an interaction of effects between the two factors, the gender of counselor and the type of counseling used. So statistically, we can see that the interaction here in our ANOVA summary table, that the interaction for gender and type is significant. Thus, we have rejected HO. And this information is very significant in our analysis because we can see that the two main effects of the factors, gender of counselor and type of counseling, are not significant. However, these factors could be significant depending on the level of the other independent variable. For example, here, in the emotion-focused kind of counseling, in the emotion-focused type of counseling, there is no significant difference in grief scores between clients who received counseling from both the male and female participants. However, when it comes to the use of psychoanalytic type of counseling, we can see that there is a big gap in grief scores between clients who received counseling from a female counselor and those clients who received counseling from a male counselor. We can see that the clients under a male counselor using psychoanalytic type of counseling had increased grief scores than the clients with or under a female counselor. Both are using psychoanalytic type of counseling. Now, when it comes to the use of behavioral type of counseling, the scores of the clients under the male, okay, between clients under male and female counselors are just about the same. Although the clients with a female counselor using behavioral type of counseling, their mean score is higher than the clients under a male counselor, but they are not statistically significantly different. So it is here, there would be an effect of gender on the grief scores of clients if the type of counseling used is psychoanalytic. Okay? If otherwise, gender wouldn't have an effect on grief scores if the type of counseling used is emotion focused and behavioral focused. So we can note a significant difference in grief scores between clients under a male counselor and under a female counselors if the type of counseling used is psychoanalytic type of counseling. And we can see here that the interaction, the effect size represented by eta squared, the effect size of the interaction is large. It is 0.3554. So we can interpret that as 35.5% of the variability in the grief scores of the participants can be attributed to the interaction between gender of the counselor and type of counseling used. So that we have not violated the assumptions of Way Anova. So ang gagawin natin dito is to reformat our data. Okay, Control M, so we can do normality testing. Okay, ANOVA, we have two-factor, and we check, we have to highlight our input range and check reformat. And we have number of rows per sample. We have 5. And we have our output range. We put our output range so this can be reformatted. And then we can now check for normality. So here, we can see that we have here a 3x2 presentation, a 3x2 presentation of our data. Dito, we have aligned, okay, we have reformatted the data in such a way that they are aligned in this way, which would be available for one-way ANOVA format. So we then again click Control M and we check descriptive statistics and normality. And we now highlight because this is now available for one-way ANOVA format. So we can check for descriptive statistics. So we check descriptive statistics, box plot with outliers. We check for testing of normality, Shapiro-Wilk, and we check for outliers and missing data. Have here output range. Okay. So for normality, we have here the box plot. The box plot would tell you whether there are outliers. Although you don't need it because these charts here would also tell you whether there are outliers. So here is, if we will look at the kurtosis of all 6 groups. These are the kurtosis and these are the skewness. So ang medyo mataas dito ay 2.64, 2.75, 2.47. But if we will look at the Shapiro-Wilk, the Shapiro-Wilk says that all 6 groups, okay, all 6 cells have normal distribution. And are there outliers? It says that there are no outliers in these cells. So we're able to check homogeneity of we're able to check the normality assumption, and there are no outliers. Now, for us to check for homogeneity of variance, we click Control M again. Check one factor ANOVA and check, go back to our input range. So this is our input range. And we check Leven's test. And check our output range. We click OK. So the Leven's test says that the homogeneity of variance is somehow this is 0.02, the p-value. So we can say that there is a heteroscedasticity. The variances are not equal among these 6 groupings. However, let us just assume that this is okay. Anyway, for the sake of demonstration. Okay, so that is our data for this study. We have seen that there is no significant difference in grief scores between clients who had a male and female counselors, and we also have also seen that there is no significant difference in grief scores among clients who went through different types of counseling. However, there is an interaction of effects between gender of counselors and type of counseling used on the grief scores of our clients. Okay, so we can now make our reports. So there will be, I will not anymore discuss it here in this video. I will just send you the format on how to report the results of two-way ANOVA. Okay, so that's it for this lesson video. You have learned how to perform two-way analysis of variance using RealStat. And you also have learned what are the conditions or when do we use the two-way analysis of variance, what are the advantages of using two-way analysis of variance, and what are the assumptions that we have to check before using the two-way analysis of variance. Okay, so that's it, guys. So thank you for watching this video and see you in our next lesson.